Hello everyone, we're gonna today do an example on STM32 while blinking an LED, doing some initialization. So I would like to start up STM32 right now. So if you haven't installed it, please install it from STM site. Takes a while to load up. And when it gets started, the first thing that you have to do is to start up a new file from up here. As you see, STM32 project. You click on that from the top. It initializes the STM32 target selector. The first thing that happens is we have to select the device that we will run. So you have to select the device that you need that is connected to your device. For my case, this is STM32CUBEIDE RET6. I click next. I type in the project name. The project name happens to be an LED blinking LED with at the button press. So LED_button is the name of my file. I click next. There is nothing to update here, so just click on finish. It loads the IOC file. The IOC is the internal configuration file that enables us to do quick startup with the ELE of STM32. Takes a while. It finishes up, and you have your chip in front of you right now. All you have to do is to select. You have to select the inputs outputs for our example. So what we're going to do is we're going to select port A5 as the output, GPIO output, and port C13 as the GPIO input. I can name these differently when I go into those, which we can enter labels such as my button. And I can change that PA5 to be my LED. So I just changed those names. I have nothing else to change here, so I just check on the other parameters here. One thing that I have to do is I have to get into SYS over here on the left hand side in the system core. And I have to enable the debugging with serial wire. So serial wire has to be set in this case. Okay, and what I can do is I can come into the GPIO and check on the values for PA5, PC13, that they are there. I can verify them. I can change some parameters here. I can change the initial values for PA5, for instance. I can make them pull up, pull down, whatever I like. So I click save to save my file, and it generates a code automatically for you with the HAL libraries, AJAL libraries for the STM32. As you see, a file with main.c has been created. It seems like a long file, but many of them are just comments that you can write your own code. Right? And what we're going to do is we're going to come down to the statement in main code, right here. And we're going to come down to while statement. There's a while one statement. So everything is going to work in this part of the code. So I come down there and I type the necessary code for my application. Now I need a button that I need to check. So the first thing that I'm going to write here before the user code and while statement, I'm going to type in a value for t. That's a parameter that I check for the button press. So if it's a button is not pressed, I have a 1 signal coming in. I have a 0, that means a button has been pressed. So I can check on that with t value. The next thing that I'm going to do is I'm going to set up a while statement here, underneath here, that goes on in this while statement and checks on the values of t and also within the loop itself. So this is one version I can do. I can check on GPIO C, the input data register of the GPIO register for port C, and I can check on the 13th value in this. So this is 2 represents the 13th value. That 1 over there in 2 represents the 13th value. So I can mask that out and I can look into that value. If it's equal to 1 or any other value other than 0, then I need to stay there, stay in the loop as long as that value is equal to 1 or any other value different than 0. So I continue afterwards by writing into the GPIO position. I'm using the HAL library here for a change, and HAL GPIO write pin is equal to 1. Next, I do the same thing again. This time I need to move my finger off the button. Okay, so I have another while statement that checks on the t value, but this time t has to be equal to something other than 0 to move on to the next statement, which is going to be the turning off the LED. So that's another HAL statement that turns off the LED. Okay, so at this moment I can build my code and make sure that it goes perfectly fine. If there are no errors, then we're all set. Okay, there are no errors, no warnings. One thing I can do is, while I'm here, I can go to a statement before the while statement. As you see, there's a user code begin and user code end statements. I can type in here a variable, which is counter, that's going to be incremented once I have a button pressed. So I can increment that counter after I press the button safely. Well, I cannot visualize this at this moment, but what I can do during the debugging, I can check on this counter value and see how many times I pressed this value. The other version for this could have been, I could have read a pin for GPIO. I'm writing this also here. Instead of checking on T, I'm putting a comment here with that statement that is reading that pin through GPIO directly. So I could have written a HAL statement instead of writing into that IDR register directly. I can also do something similar for writing into the LED position for pin 5. Okay, that's going to be the ODR register. I'll leave that as an exercise for you to try it on and see what it goes, how it goes. Okay, so I'm gonna save again this file and build the project once again. In the console, it's going to show, it has to show that I have no errors or warnings. At this moment I can run my code and see if that code really works on my device. Okay, I just click OK here. There's no debugging option I need to set. Once it finishes, just check if your device is actually working as you intended to. Now at this moment, what you can do is you can, once you have verified it works fine, or if it doesn't work fine, you can check on the debugger, there's a bug at the top, as you see here, and it takes you to a different screen where you can step by step go through the code. So it is in this statement right now, and you can click the step over button at the top, as you see, and you can go step by step to the other statements in the code. So it initializes the HAL statement, it initializes the system clock. So what you do in the assembly language also done in HAL libraries in the procedure below. There's the GPIO initialization. The thing that we have done in IOC file is reflected into this procedure. Initializes the counter, that we have already done that. Takes the value of t. Now t is a value that you can check on by just adding that into a watch expression list. So I can add that into the expression list on the right hand side over here, and I can see its value. Since I'm pressing the button here, it just goes on with the code as I intended to do. So I step over, goes to the next line, turns on the LED, and then waits until I move my finger off the button. So it just stays in this loop, and waits until I remove my finger off the button. Now what you can visualize also, the counter value. The counter value becomes, as you see here, 1. So every time you press the button, the counter is going to be incremented once again. Okay, so you just stay in the loop, and then when I move my finger off the button, it goes on and it turns the LED off, and it goes to the beginning of the while statement. Okay, so that's a short tutorial on how I can get started with STM32. Please do the same. Thank you for listening. Bye bye.